Calculating a chi-square goodness of fit or a one-way chi-square. This is done when you have one nominal variable. Basic formula: chi-square equals sum of all observed minus the expected squared over the expected. O is observed, E is expected. Steps: first step, write our hypothesis. Second step, determine observed values. 3, calculate expected values. 4, calculate our chi-square obtained values using the previous formula. 5, look up our chi-square critical value. 6, decide whether or not we reject the null. So for our example, we're assuming that, or taking a look at whether or not the color of a car influences the number of speeding tickets. We observed red cars getting 20 tickets, blue cars getting 15 tickets, and white getting 10. This is going to give us a total sample size of 45. So our null is going to be that all of them are equal. Number of red tickets equals the number of blue tickets equals the number of white tickets. Our alternative is at least one frequency is different. This is important. It's not all. It just needs to be one different. Alright, so step 2 is our expected equals our percent for each category times our total observed. So it's all expected equals a third, because we have 3 categories and we have no prior information that there's going to be any difference among them. So it's going to be a third times 45, which equals 15. So each of our expected categories is going to be 15. Calculating it out, we just unfold our chi-square formula. So we're going to have 20 minus 15 squared over 15. These are the information from the previous table. 15 minus 15, because this is the proper cars, blue minus blue expected over blue expected. And then we just do the basic formula: 5 squared, 0 squared, negative 5 squared, each over 15. So it becomes 25 over 15 plus 0 over 15 plus 25 over 15, which gives us 50 over 15, which gives us a chi-square obtained of 3.34. So next we got to do step 5. In order to calculate our alpha and our critical value, more importantly, we need to know our alpha, which is 0.05, our number of categories, which is k, our degrees of freedom, which is k minus 1. In this case, we had 3 different categories: red, blue, and white. So our degrees of freedom is going to be 3. Minus 1, which equals 2. Chi-square value we're going to look up. We have alpha of 0.05, 2 degrees of freedom, 5.99. This leads us to our 6th and final step, rules for rejection. If our chi-square obtained is greater than our chi-square critical value, then we reject our null hypothesis. So here we can draw it out and determine that this over here is the rejection region. Our obtained value does not fall in it. So therefore, we do not reject the null. We fail to reject the null. Conclusion: there is no meaningful difference between car color and ticket issued. We fail to reject the null because the obtained value does not fall in the critical region. Thank you very much, and I hope you enjoy my other videos.